Okay, well, what we're going to talk about is a project that I've been working on for a few days now. I'm a consultant and I design various control systems for a client I have in Brooklyn. And if you look under my handle, you can see many videos I've taken of his projects. Anyway, so I'm always working like almost a year ahead of time for Christmas because that's primarily the product, which are custom displays, usually for the Christmas holidays. And they're always animated with figures, with lighting and sound. So here's a early concept sketch of the project at hand, which is simply the 12 days of Christmas. So in the center, we have a rather tall tree. It's about 25 feet tall. It'll be sitting on this inner pedestal, which is 8 feet in diameter, which in turn is surrounded by this other pedestal, which is 14 feet in diameter. The lower pedestal will have 12 locations, one for each day of Christmas, as in the song, representing all the various characters they sing about. So a control system is needed to control the lighting on the tree, the motors and lighting for each individual day that's being sung about. There'll be some other ornamentation, like there'll be some small trees that'll have lights on it. There'll be some garland around the lower pedestal and some around the upper pedestal. All in all, it works out to about 36 separate power circuits. So I needed to come up with a way to handle all that under budget and on time. You've heard those words before. So it seemed to me for this large number of power circuits that have to be controlled, maybe the best way is using something they use in theaters all the time, which are DMX controllers. I don't have a lot of experience with DMX, but I knew about it, and it certainly seemed like it would have the capability. So could I find a controller out there to purchase that took care of everything we needed this to do? And my list of wants and needs included things like something rather small, not too big, certainly smaller than a rack mount unit, not too expensive, got to stay under budget. Something where we could store the performance on an SD card or somewhere memory device so that they could be swapped out easily. I need something that was totally standalone, something that you could just plug in the power and it would automatically turn on, and there was nothing more to do, just watch the show. For that, we also needed something with a built-in time of day clock with a scheduler so that we could schedule performances to occur at certain times during the day. Of course, it needed to have a DMX interface so it could plug the controller into the various fixtures that were needed to control the different elements of the display. Also, we needed a built-in player, audio player, MP3 player, that would play the song in coordination with the lighting and other animation control. And as a bonus, it would be nice to have a remote control, a feature of some sort, so that if it was necessary to start the performance, sometime in between the scheduled performances, it could be done so at a push of a button. So that's where we started. Now, you could go to some of the professional manufacturers of theater controls, maybe Builder Fluke or some of these other folks. And if you're willing to spend $1,000 or $10,000, you can find something very nice. That was out of budget, totally. The other direction would be to be totally do-it-yourself. Sit down, an Arduino, add the time of day clock and add the DMX controllers, etc., which is certainly doable. Be a fun project, but I just really didn't have the time to sit down and do that. Anyway, so I went and searched online, and I came across these folks, which some of you may already know. This Brookshire software. He had a small standalone unit, which essentially had all the features I just described. And we'll go over them one by one. Here's a block diagram showing you what they are. Here's a slot for your performance, USB port to do testing and also load up the memory card, optional infrared remote control, internal clock with a scheduler, a serial port for external control, a device port if you were interested in controlling motors and relays and servos and things like that, which I was not, but that's nice to have in there. This is what I really wanted, which was the DMX output. And of course, it had the audio capability with stereo. So I looked into it. Price was not inexpensive, but it was acceptable as far as the budget was concerned. So we bought one and a spare. Got to have a spare because you never know. Anyway, this is what it looks like in the flesh. And let me zoom in a little so we can get a better look. That's pretty much what you get in the mail. It's a bare board with various push-button controls, the LCD display. You can see some of the ports back here, the control port and the device port. RCAs for audio out. On the side here we have the DMX port. In the front is where the SD card would go. And then this little guy sticking up on top would be the receiver for the IR remote control. So, and in addition to the hardware, I'll just turn it over so you can see what the back looks like. You get a better idea what those connectors look like. Here's your real-time clock. In addition to this, of course, you need to be able to program it. The same company offers programming software, which is purchased separately, which I purchased. It comes in various flavors depending on the level of sophistication you need for your particular project. So that's where I started. I had some problems, though. The manual that comes with it is a little short on words. Like me, who's an engineer, we're not very wordy guys, and we try to keep it down to a minimum, nice and efficient. But unfortunately, it's a good manual if you know what you're doing. But being the first time, never used this product before, I struggled with it a little bit. I did have some back and forth emails with the owner of the company, and he helped me along as best he could. And we got started. However, it would have been nice if you had one of those, hello world type examples where there's a lot of hand holding. You put this plug in here and you do this, you push this button, and this is what you should see. And that would have gotten me past the first couple hours anyway. But with a little hit and miss, I got this going on myself. So one of the things I needed to do was a couple things. One is I had a package. Obviously, I'm not going to deliver a product in this condition. It's too vulnerable, and it would be exposed to elements, to accidental conditions, if you know what I'm saying. Anyway, so I was able to find a relatively nice package. Here we go. Here we go. Pull back. So now this is in a fully enclosed container. It's got mounting flanges on the side, good for mounting. I drill holes for access to the various ports for this audio, for power, for DMX, for the programming memory card, etc. But I also had to deal with this remote control issue. As I mentioned before, there is a serial port in the back with DB9, which is designated for the serial interface. Following the directions as best as they were provided, I was totally unsuccessful, or at least partially successful, in getting to communicate with the board. Sometimes it would accept commands, sometimes it would not. So I didn't know if it was a baud rate problem or a hardware problem, who knows what. I tried to verify my command string as best I could by just having my PC, in terminal mode, communicating with an Arduino that I put together that I had intended to use to communicate with this. But despite using either the Arduino or the PC, I still had difficulties. I even tried my second backup board just to see if that was part of the problem. It was not. I had the same basic problems. So, what to do? So, this is what I did. As you can see, on the front we have this IR sensor. It's a typical kind of IR sensor you might see like in a TV set or some other device that uses infrared control. And it would be used with a common controller or something like this. This is the one that actually came with the... This is the one that actually was provided with the unit. Nothing fancy, off-the-shelf controller. And so the board is designed to receive certain signals from this remote and perform certain functions. Even though I tried it and it seemed to work, there was no way I was going to hand this off to a client because, number one, it's going to get lost or stepped on. Number two, it's got too many buttons. I only wanted to perform two functions: start, stop. Very simple. And although it was possible to do it with this, it didn't seem like the practical way to go, at least not in this configuration. So what I did is I took a closer look at the infrared receiver, and unfortunately it did not have any markings on it, but that's why we have test equipment. So with a multimeter and a scope, I was able to identify the three leads. One is ground, one is power, and the third one is the output signal. So, which is kind of what I suspected. The big question now is, what is the nature of the signal? So in order to do that, I just pressed one of the buttons on the remote and looked at what came through on the output pin of this device, and there you go. And the numbers you see here are the time numbers, are just numbers that I pulled off with my oscilloscope. So having this in hand, and I looked at a couple of different other push button commands, I could get the flavor of what this was all about. And it was a 12-bit protocol, and while searching around, determined it was the Sony protocol, and this information is readily available on the internet, so you can figure it out yourself as well. So I said, well, and here's another page I found with more timing information on it. But it's pretty straightforward once you see what it's all about. So what I wound up doing was building this device, which is basically a nice little blue box you can get at Home Depot or at Lowe's or equivalent. And there's my two buttons, start and stop. It's all based on a little Arduino Pro Mini, and it's got two routines in it that detect which button is pressed and outputs the appropriate serial data stream. And I pulled out the IR receiver that was soldered into the board, wired this into those same pads, and it works like a charm. How about that? All right, next thing we can do is take a look at my programming setup. I needed to simulate the loads, mostly just the number of loads that we had intended to work with on this project for the tree lights and for the animation. And as I said, it came out to about 36 circuits, AC circuits. I wanted to set up a real practical load situation that was somewhat configured in the same physical relationship as the full final project. So let's take a look at that.